This is Brian Putt. Today I want to talk to you about aggregating subject matter expert assessments that are gathered independently. This is the recommended thing to do, is to gather them independently, but then I do agree that you might bring them together and maybe they can agree. There may be different things they hadn't thought about. But let's assume you're not going to do that and that you're just going to take the two assessments and want to combine them in some way. So let's assume that you have two assessments, a distribution 1 and a distribution 2. They're both triangular. Now, I recognize you may not get full distributions like this, but the process I'm going to talk about for combining them would apply in all cases. So it's a triangular distribution with minimum, most likely, and maximum. And distribution 2 is shown here. And they are graphed down here. So you can see they're very different. Distribution 1, subject matter expert 1, is very optimistic that, or maybe if this is cost, think of it as pessimistic. Pessimistic, the cost is going to be higher. And subject matter 2 is more optimistic, with the cost being lower, much also lower range of outcomes. So how do we combine these? Well, there's two ways to do it. Actually, there's several ways to do it, but let's talk about maybe three ways. One is to pick a probability, let's say 40%, and weight these two values. The other possibility is to pick a value, let's call it 60, and weight the 2 percentiles. Now, of those two ways, the recommended way is to pick a value and weight the 2 percentiles. That's the recommended way. The other way you could do it, a third way you could do it, is simply Monte Carlo both of them and just average the results. In doing that, though, I think you need to be careful that, in general, if one of them, if the project's going to go pear-shaped, it's probably going to go pear-shaped on both of those curves. So in other words, if I'm going to be down here at the, say, the P20 for the project on subject matter expert 1, I'm probably down on the lower segment matter expert 2. It's not likely I'm going to have a result down here and a result up here to average. So if you do that, I think you need to make them correlated in some manner. Whether that's 100% or not, I don't know. But I'm not really recommending that way to begin with. I'm going to recommend that you pick a value here and average the 2 percentiles. So how do we do that? What's really important is to think about the endpoints here. We need to make sure that we capture the full range of values for both of these subject matter experts. We're going to do that by calculating the min and the max of the distribution that I've sampled from this triangle. So this didn't come up to 150, it came up to 182. That was the highest number I sampled, and the minimum was 30.87. Those that are working with SIP math can see that equation. And then similarly, we take the same numbers, minimum max, for the distribution 2. Now, if I want to take a value here and average the percentiles, I can only average them between here to here. If I tried to average them at, let's say, 110, I only have one distribution. So I am only going to sample between 30.87 and 77.66, which represents the maximum of these minimums, and this represents the minimum of the maximums. All right. So now what do I want to do? I need to randomly select numbers between these two values. I'll do that with this equation here by taking the difference and multiplying by K9, which I believe K9 is just a uniform distribution. Multiply that by K9, and then add the minimum of 30.87, and that's going to give me a distribution of these two numbers equally distributed. Then what I can do is calculate the percentile for subject matter expert 1 and 2 at this value. So at 20, it's 70.5. The percentile for subject matter expert 1 is 53. So it's 70 point. Let's put a line in there. That's 70.5. So that's right about there, right? So for this guy, it's 53, we said. And for subject matter expert 2, it's supposed to be 96, and that's what it is over here. So you can see those are the 2 percentiles I pulled off for 70.5. And then I can average those percentiles to get 0.74. Now I'm going to do this in a Monte Carlo perspective. Now I ended up with 1,000 of these things. And from a SIPMath perspective, the way it's calculated, I can come over here to this PM table, and I can see those 1,000 trials. Here is my 70.5, and here's my average P of 74. And there's 1,000 of these things going down. All right. That's all well and good. So now what do I want to do with that? How do I use that to put it into my model? That's what I really need to do. I don't want to have 2 equations. I really don't want to store 1,000 things. I really want to store just one equation, that distribution, which represents the average distribution. What I'm going to do is I'm going to take it over to a metalog file. And there are 2 metalog files that were developed by Tom Keelan. One is for equally weighted results, and the other is for percentiles. So what I'm going to do is I'm going to use the percentile one, and I'm going to plot this percentile versus this value. So let's go look at that file now. Here's the file. And this is downloadable from metalogdistributions.com. And what I've done is I've stored the results here. But really what you want to do is you want to come in here and put in the results. So these are the results for the percentiles, and these are the results for the values. And we put those in, and we see that that distribution looks like this. I mean, we just sampled between here, but we know we want the endpoints to go out to the 2 endpoints of our distribution here. Well, I extended this down to about 10, and I extended this up to 150, I believe it was. Is the right file? I went to 160, I should have said. Okay, so it's 10 to 160, so I put in 2 data points here. And with that data there, it then fitted all that data to this distribution. It looks pretty good through here, and it goes to my 2 endpoints, and it looks pretty reasonable. It looks pretty reasonable. So I still have to get that over to my Excel file. So what I do is I say, so we're going to say make metalog dist function, and that generates this distribution down here, which is then also reflected over here. And I can copy these 3 cells, or I can take all 9 of these if you wish, and bring them over to my other model. And that's what I've done over here. The only thing I need to do is where this y is, that's supposed to be a random number between 0 and 1. And so I have made that equal to this thing, which is a uniform distribution. So now the proof of the pudding is if I can plot this graphic, this distribution, and make it fit between these 2. So if I graph that, bear with me, I've already done that. I'm just going to add it in here. And there's my consolidated distribution for these two subject matter experts. And the question becomes, you have to ask in your own mind, does this look like a reasonable distribution to average these two assessments? It fits the full range, and it kind of comes in between these two. So I hope this how-to video will help you consolidate subject matter expert inputs. And whether you've got 2 or 10, you could do the same thing. All you need to do is to look up all 10 and then average those, right? And once again, you need to go through this process here of finding the max of the mins and the mins of the maxes. If you're interested in getting this file, let me know. Be happy to send it to you. And you can reach me at brian@theputz.com. Thank you very much. Bye.